Hey everybody. All right, it's Miss Moran in M308 Advanced Algebra 2. We're starting our second standard of the first unit here. So go ahead and write at the top of your notebook paper, determine the solutions to linear equations. That's the standard that we're going to be working on for the next few videos. Determine the solutions to linear equations. The video reference number is video 1.2.1. Remember that is unit 1. Standard 2, and it's the first video for this standard. And specifically, we're going to be working on inverse operations and solving linear equations. Remember to pause whenever you need to catch up or to write something down or make any additional notes or, to run to the bathroom. All right, let's go ahead and get started if you're ready. So we're going to begin and talk about what inverse operations are. You know what inverse operations are, you just might not know them by this name. So an inverse operation is an operation that undoes the initial operation. So these are operations that undo an initial operation. What the heck does that mean? Well, let's just think about this. There's some operations, or there's lots of operations. Let's say I start with a W. And I say, okay, I'm going to take this W and I'm going to add 5 to this W. How can I undo what I just did to that W? How do I undo adding 5? Oh, I can subtract 5. And what do I result with? The original W. So it gets you back to the start. This is an example of a pair of inverse operations because inverse operations come in pairs. You need to have two. One that does something, that's your initial, and one that undoes it. Okay, so those are inverses. And these inverses are adding and subtracting. So addition and subtraction are inverse operations, okay? So what about, let's say we start with that W again, and I multiply this W times 2. So now I have doubled the value of W. Well, what if I want to undo that? How do I do that? So I take that 2W and I can divide it by 2. And what is my result? I get back to the original W. So we found another set, and they are multiplication and division. Now, remember, either of these could be the initial. I could have started by dividing by 2, and then to undo division, I would use multiplication. So neither one is more important than the other. They could go in either order. So think of some other ones. What if I take this W and I want to square the W? How do I undo squaring a value? I apply a square root. So this gets me back to my original W. So we have squaring and square roots. These are another example of inverse operations, and we're going to come up with plenty of inverse operations throughout this course. These are just 3 examples. You can probably think of some others. Now we're going to use this idea of undoing something to a particular variable, and we're going to use that to solve some equations. Let's keep going. All right, take a moment to write this down. We have the equation 3 times this quantity of 2x minus 5 equals 9. And we're going to use inverse operations. Your instinct on this might be to distribute. And I'm going to ask for just a moment for 2 or 3 examples that you try it my way, because this is a method that will work no matter what operations I give you. If we can identify one operation's inverse, then we will be able to solve so many different equations you have not even thought about. I'm going to use this linear equation, this very simple, probably the first type of equation you solved in Algebra 1. I'm going to use that to help you understand the process. So this is what we're going to do. We're going to think about what happens to x. So if I'm looking at x specifically, I think what's the first thing that we would do if I put a value in for x? And the first thing we would do is we would multiply it by 2. Okay, so now we'd have a value, and then after we multiplied it by 2, then we would have to take that thing and subtract 5 from it. And after we subtracted 5, then we would multiply by 3. So again, the order of what we just did is we started with x, and we multiplied x by 2, we subtracted 5, and then we multiplied it by 3. And the result of doing all of that is we got 9. So if I want to undo what happened to x, and what we did was we multiplied x by 2, that's the first thing, then we subtracted 5, and then we multiplied by 3. If I want to undo those, I have to do them in the reverse order. So I start with 9, and I say, okay, we're going to divide that by 3. And then I'm going to add 5, and we get 8. And I'm going to divide by 2 using inverse operations, and I get 4. So I know that x equals 4. You're welcome to go ahead and pause and see if when you distribute you get the same value. Perhaps maybe you've already done that. But consider the fact that all I did was line up what operations were originally applied to x and what operations can undo those, our inverse operations. Let's try another one. I'll give you a moment to go ahead and write that down. Press pause. All right. So the first thing we're going to do is look at what happened to x. And I think the first thing that happened to x was we multiplied it by 6. Then we added 14, so we took care of this. Then we multiplied it by a half. And lastly, we subtracted 4. The result of all of that was we got an 8. So let's undo those from the bottom up. I will have to add 4. That gives me 12. Now here's two options. I could divide by 1/2, or I could multiply by 2. Both of those will do the same thing. Be careful when you're doing it in your calculator, but they're both inverses of multiplying by a fraction. I could divide by the fraction, or I could multiply by its reciprocal, and we learned that in a previous video. So I get 24. Then I will subtract 14, and I get 10. And lastly, we will divide by 6, and I get 10 over 6, which I can reduce to 5/3. So x equals 5/3. If you're going to write 5/3 as a decimal, please make sure that you're using the repeated bar above the 6. So that would be 1.6 repeating if you wanted to write it as a decimal. Let's try another one. Give you a moment to write this down. Pause if you need to. All right, so here I've got a big equation, and it looks like I've got x's on both sides. And this poses a problem with this method. So I am going to have to get all of the x's into one spot and on one side of an equation. So I will need to use a distributive property and maybe a little bit of collecting like terms. Let's go ahead and try that. On the left-hand side here, I'm going to just combine the 5 and the -1. So I will have 3x plus 4. And on the other side, I'm going to have to distribute the 8, giving me 40 minus 16x. I said all we have to move are the x's. And I'm going to use inverse operations to do that. In order to undo this minus 16x, I would have to add 16x. So I will add 16x to both sides, leaving me no x's on the right-hand side, and I have 19x plus 4 equals 40. From this point, we know it's only a two-step equation and it only requires two operations. I'm going to make the chart because I'm going to continue in the manner I started. And that would be what happened to x. 19, we multiply by 19, and then we added 4. The result was we got a 40. Working my way back up, I will subtract 4 and get 36, and I will divide by 19. 36 is not divisible by 19, so we can leave our answer as 36 over 19, and it cannot be reduced. All right, I'm going to go ahead and try one more with you. All right, here we go. If you haven't written it down, go ahead and pause, but we're going to get started. And again, I'm going to have to do a little bit of distributing and combining like terms to get all of my x's in one location. Go ahead and start with that. On this side, I have to distribute a -1 because I'm subtracting the entire quantity. That is 2 minus x minus 1. And on the other side, I have 2x, and now I have to distribute the 3. That gives me 12x plus 15. I'm going to combine like terms. On the left-hand side, I have a 2 and a minus 1, which means 1 minus x. And on the right-hand side, I have to combine my x's, which is going to be 14x plus 15. Once again, all we need to do is put all of our x's in one location, and I will use an inverse operation of addition to make that happen. And that leaves me with 1 equals 15x plus 15. From this point, you can solve this using a two-step equation and just go ahead and follow those two operations. But we're going to continue in the manner I started. I'm going to multiply by 15, and I'm going to add 15 is the next thing that happened, and the result was a 1. Working my way back up, I will have to subtract 15. That gives me negative 14. And I will have to divide by 15, which I know that negative 14 is not divisible by positive 15, so we will just leave it as negative 14 over 15. And these are the best answers. Decimals are not really appropriate for this case. All right, go back and watch anything you've got. If you need to ask any questions, go ahead and post those on Schoology to the discussion. And finish the entrance slip on Schoology.